Yes, so this is Saket. So we are back again with another concept of dealing the importance of data. So today we're going to see about how we can build a simple classifier using an advanced library, which I can call it as a machine learning library called as Scikit-learn. So the prerequisites are you need not have any knowledge about that because if you make if you make something like your logical thinking to it, then you can easily understand. So how does this thing related to, even if you have attended the previous webinar, we have done on regression concept. So we are dealing with the field of AI and how data is related to this field, right? So again, I say when I talk about machine learning, it is a subset of AI where the ultimate task is to make computers learn by themselves. So in that, we are having the concepts of the different types of learnings include supervised learning, unsupervised learning, and reinforcement learning. So I always suggest the same thing, Andy. You need to compare the when you need to compare a machine learning model or any outcome of machine learning so to a small kid, how he is learning from his experience, because it only deals with the three concepts of how the task, how he is performing the task, and based on his experience, how the performance is being increasing. So I deal only three things: task, experience, and performance. So based on those three things only, your model is able to learn. When I say model and all, when I say model always, that means how we are training your data with the help of an algorithm. That's where the types differ. So supervised, unsupervised, reinforcement. So before dealing into those things, it is not simply an algorithm, and just machine learning is not simple like programming, because always I tell machine learning and programming are completely different. Because in traditional programming, I'll compare both of them so that if you go for input, processing, output. So basically in standard programming, you define the input, right? So you define the input. How do you define the input in standard programming? Yes, exactly. That can be your data type or the alphanumeric symbols. Scanf is not for defining the data type. It is just to store the type of data. I asked how you initialize your data. Right, so that can be of different type. Some may say data type, some may say input statements or anything. So in basic standard programming, yes, so you define input with a sequence of alphanumeric symbols, right, where you pass through a media such as keyboard or mouse. Whereas in machine learning, we input the data in the format of image, audio, or data. That means image or image data or audio data or text data or numeric data. That is the reason Python is the suitable programming language for data science or whatever you take the subsets of it, the machine learning. Yes, so because whatever the data you see in real senses, that is numeric data, which includes integer, float values, and characters. If you go for text or strings, string is nothing but the group of characters. So that's how you take up the real senses. Even if you take up the examples of Alexa, Siri, OK Google, and you take up the same thing. If you go for image recognition or videos, image data. Again, image data is nothing but group of pixels. The same thing will go on, right? So if you see for standard programming, you have this type of data. For machine learning, your input can be any of this type. So the flexibility where Python provides is you can directly take out the files concept. So that thing is for any kind of data, .txt or any file format. There you use pandas. So that's how we have been dealing from the previous sessions. In today's session also, you'll be learning something new thing, that is in input type. If you go for processing, so here the standard programming, that can be Python, Java, C or C++ or any kind of programming. Processing is about making manipulations, right, by set of some defined algorithms. If you go for machine learning, here processing is all about demonstration of knowledge. Whatever it has been trained from the previous data, it will learn based upon the patterns. So that's where this learning types comes into picture: supervised, unsupervised, reinforcement. Because I'll discuss these things, but in the meanwhile, let me talk about the output also, because always everything in real terms, you equate y is equal to mx. Your input is equal to output. That's where we have started learning from our childhood linear equations. That is related to polynomials, quadratic equation. Then you relate the thing to statistics, statistics to predictive modeling to machine learning. That's how the generation of data has been emerged in software. If you go for hardware, you see computers, laptops, tabs, iPads, all these things have been emerged. In the same way, if you see the output of anything, the output can be series of data which you can visualize with a paper or on a screen. EC guys will see on cathode ray tube screen, a computer guys will see the output on the monitor. Whereas if you see the output of machine learning, that is a series of mathematical functions where you try to find out that thing with the help of performance measures. Where you see in which we have seen in the previous session, we have gone for regression. That is, you find out the score parameter and mean square error. If you go for classification, that's where you dig out into performance measures, which includes confusion matrix, classification report, accuracy score. So that's how machine learning is different from standard programming. So in the types of learning or in the processing stage, you have these three steps, which include supervised learning, unsupervised learning, reinforcement learning. As I always say, supervised, it is always task driven. That is something like your parent guiding you, or you are being guided by your faculty. Because our mother is the first parent, or our father is the first parent, first teach, not parent, first teacher, because we learn at our home, right? So that's how we start learning the data. Yes, am I right? Your parent is your first teacher, where you will learn from them how they speak, how they tell us to write, and how they do. In the same way, if I talk about supervised learning, that is task driven. That means you'll be having a set of data where you have the input, where you have the target, you need to map them. That's where the mapping concept comes into picture. Where we have studied about the regression. Now we are going to see how we relate the different type of data to a classification model. So classification is nothing but you are dividing the set into categories. We'll be seeing that thing in the coming minutes. So this is the intro for it. If you go for unsupervised, it is something like you don't have anything in common. You will leave everything to the data that should learn from the data itself, which is unlabeled. If you go for reinforcement, it is something like you learning from mistakes, because we learn from our mistakes, right? We learn from our mistakes in our daily life so that to make our life better. That can be in our studies or career or anything. We learn from our mistakes. So that is how reinforcement. That is the reason you get either reward or penalty. That is something like you see the Sophia example, which I've been talking from the beginning. So if you see Sophia or any kind of outcome where you relate that thing as recommendation engine or reinforcement learning. So recommendation engine, whatever you use, Google or any kind of speech assistants, those are called as recommendation engines, where they'll give the output in the format of voice or the result in the format of text. That is how the things goes on. So if I relate the things, the general things, machine learning, the general it is supervised and unsupervised, it is into division of the things. You generally have the main types of regression classifiers or classifiers. You see, in classification, we have decision trees, ensemble models, random forest, and SVM, naive Bayes, and all the things. In regression, you have linear regression and all these types. So we are trying to make you aware of the basic things, how we need to build a model. So in the previous session, we have seen for linear regression, and now we'll be seeing the first most important multi-label classifier, which is decision tree. That's what we are going to see in today's session. But before that, you need to understand what is classification. So I suggest however I learned, I'll try to train it in the same way. I try to relate the same things to real world, because what I learned 4 years back when I completed my bachelor's, when I'm into masters of computational intelligence, I learned that whatever we missed in our academic curriculum, we need to relate that thing to general life. So that paved interest towards Python programming. Then we are into the data science field into training and development, where we relate this term to general life. It is something like if you see about classification, what do you mean by classification? It is a problem of identifying to which set of categories some observation belongs. Yes, in general life you classify, right? We classify the things whether they belong to some one set or another set. Even students are being classified into, see, if you sit in exams, they'll be classified into based on their things. If you see in schools, boys one side, girls one side, in that way they'll be classifying. So based on the kind of place we live and based on the kind of thing. If we talk about the same thing, so if my data set is about, I need to categorize it into some groups based on my input, so that based on this kind of data, whether it belongs to this category or that category. So that's how the classification terms comes into picture. So only two types in supervised, that is regression and classification. So regression is about how far you are trying to give relationship between your dependent variable and independent variable. So independent variable is X, dependent variable is Y, right? So in the same way, here in classification, you again form the relationship, but you try to make that thing into different categories, whether this follows into this category or this follows into that category. Because this is supervised learning, you have the target within your data itself. Your target is to match the input data to the output data. If you see there's some examples of real life, that is text categorization or email spamming or fraud detection and all these things. So that is the reason I wanted we to do today something like based on the bank data set, which is of 10,000 rows of data, pretty good data, which similar number of columns, where we'll categorize that thing into whether they are having the deposit or not. So that's what we'll be doing today. But before that, let us know the very, very important steps, how we can build a classifier. So these steps are very, very important, which includes like this. These 5 steps play a very key role. I can segregate that thing into 4 steps where I have learned in the machine learning something like 3 years back. So this machine learning includes the 4 steps. First step is always data preparation, where the collection of data is very, very important in real senses. Because that is, if you see through online, you get some limited amount of data. If you attend Kaggle repositories, you will get some amount of data. But if you are trying to pursue some kind of research analysis, then you have only one solution, either to attend Kaggle competitions or to go manually for fetching the data. I hope you understand that one concept, because the first step or the very important task of a person who is working related to data analytics or data science, he can be that person, the ultimate target is to make his data collected. So the first thing is planning. I can say that as collection of data. Then I go for pre-processing or preparation of the data. Then my third step is creating a model. So in model creating, I go for model creation, model validation, and model evaluation. In the second step, we have seen data pre-processing. That is how you retrieve the data, how you clean the data, how you explore the data, how you go for data refining. That is the reason we are conducting webinars on the same steps. If you see, we have used data analysis by using Python libraries, where we have done the data preparation part, data cleansing part, data refining part. Then we are in the third step of modeling, where you create a model, where you go for model validation, model evaluation, right? Because in the model, that can be a regressor or a classifier. Regressor we have finished, now we are in the classifier. Once you take up the model, then what is your next step? Model creation, model validation, model evaluation. So in the modeling step, you have these pretty much 5 important steps, where every person who is working in this field, even for our teaching and for our development of any product, we are into product development also, building an intelligent engine, we use the same steps, these 5 steps, where you try to divide your data set into training set and testing set, where you train the classifier because it should be learned from the previous data. Then you go on testing it, because why do you need to test? Similar, we study in our class, we study through our entire curriculum, entire academic year, we write the exam. Why do you write exam at the end? Any answers? That can be funny also. Why do you write exam at the end of your academic career? Academics or schools, whatever you live in India or US or UK, Why do you need to write an exam? Yes, to assess yourself and to get back to the knowledge, right? To test how much you have gained through the entire academic year. And if you fail in that, then it's about only two reasons: whether you have not done your proper homework and you have neglected it. That's only two things. In the same way, when I go for, it's not about by hearting or anything. That is the childish mentality. Leave that thing apart. It's not about by hearting. It's about how you try to learn yourself. So I always prefer these four steps: planning, data preparation, modeling, model presentation. So we are in the modeling stage where you divide your data set into training and testing, where you train the classifier using some training data set, then you split them as you split it into training and testing. Because as you have said, in our general life, we follow those concepts of splitting into training and testing, because at the end we write an exam to assess ourselves. That means to get upgrade to next level. It doesn't mean an exam will assess you. It means that you are about to follow some concepts, whether that you can learn in the next stage or not. That is the main concept of education. That may be different in different countries. Let's not talk about that part. The thing is testing. Then finally, you measure the performance, and if you're getting any losses, you'll try to rectify it. However, we have been faced in our curriculum, in our academic life, we face the same things in our model creation, model validation, model evaluation. So that is how you try to make sure whatever you have learned, you try to assess it, and you try to gain knowledge from it, and you try to measure the performance, and you try to improve the model by using error analysis. So these are the steps where we'll be doing in our real life, and we apply the same thing to modeling. So remember, these 5 steps comes under modeling, but these 4 steps play a very key role in building a machine learning model. I again repeat it again. I'll come to your point. Someone asked me why training is more. I'll let you know. But make sure you remember these 4 points: data preparation, and that is planning, data collection or planning. Second step is data preparation. Third, data preparation include data retrieval, data cleansing, data refining, data exploration. Third step includes modeling, where in modeling you go for model creation, model validation, model evaluation. Those 3 steps are clearly segregated into 5 steps. So yeah, someone asked me why you should take training data more than test data. I'll answer with the simple question. You relate the same thing to your life. You have been taught only 1 plus 2 equal to 3, and in the exam you're asked to find out the solution for an equation where you need to calculate the square root of it, where you need to get the cube of the values. Can you perform it without being trained? Anyone? You have been taught only something like addition and subtraction. You are asked to find out the square root of the roots of the equation and all the stuff. We cannot do it, right? In the same way, your training data should be more so than the test data. If you are about to train more, then your model will understand that entire stuff from the data, so that whatever the new kind of data comes in the future, it will understand from the previous data, because this is supervised learning. It only maps with the previous data according to your input and target. So that is the reason we always give training data more than testing data. If you give about same level, you obviously your data is going to lose and you fall into a pit, because that cannot be worked in real life situation. The more amount of training data you give, the more your model learns, because the machine learning itself says the more data you feed, the more data it learns, because it is similar to a small kid. That is the reason we learn alphabets and we learn all the things. Then we learn into group of words, sentences, and all the things. It is not that the training data is more important than testing data. Those 3 processes I explained it manually. You don't see it in the PPT. So you try to note it down. Planning, data preparation, modeling, model. The final step is you try to present your model. Present your model it in something like you go for checking out the analysis, and finally you deploy it. That can be in your local host by using Django, or in cloud, that can be Azure or AWS. So what we suggest is, instead of going directly to cloud, try to learn to deploy your model within the user interface, where you try to relate your Python frameworks, that is lightweight framework or macro web framework Django, so that you can relate your model with the user interface, so that you can enter your values directly in the online. So that is how you can relate. Yes, so these 5 steps come under modeling stage, that is third stage. I'm repeating once again, please make sure of it: planning, data preparation, modeling, model presentation. In data preparation, we go for data retrieval, data cleansing, data exploration, data refining. These all things are be done by pandas and numpy. That is the reason they play a very key role in data analysis. Then you go for modeling, we go for model creation, model validation, and model evaluation. Then finally, model deployment. Yes, I'll come to the thing about the training ratio and testing ratio, but let me make it clear how are the steps formed. So these are the key points of any machine learning data. Yes, obviously, software engineering, data mining, data analytics, everything has been merged with machine learning. It is not that machine learning is out of the box. That's the reason we are conducting this quarantine webinars, to make sure that it is not out of the box. It is related to every field. Whoever are working on data, that can be image, text, or numeric, because we only use those type of data, then they can go for predictive modeling with the help of machine learning. That's where your model will try to learn more. You can research on more topics, so that your model will learn more things. That means a 13-year-old guy being placed as data scientist, how does he become? Because he start learning at a very early stage. He has those resources, he has those kind of parental support and everything. In the same way, if you try to make your data more, then it will try to learn more. So these are the key terminologies. I'll explain the ratio part and everything when we go into the steps, right? So these steps include data set, model, training, learning, training set, validation set, parameters, target. These are key points which whenever you come across machine learning, you come across all the things, right? So data set is nothing but collection of data. You can see model, that can be a regressor or classifier. Training is how you try to take the parameters and how you try to map them according to your input and target. Then obviously learning is your output. Whereas machine learning will make use to go for predictions. Then if you go for training data set, that is how you try to train the model. Validation is how you try to validate, and testing is nothing but how you have gone through the validation set. So target is your output, that is labels, features. I mean, features are your input, labels are your column names. Target is your y, x is your independent variable, y is your dependent variable. So these are the key terms where you'll map in everything. See, features and labels. As I always relate, the heart of machine learning, Scikit-learn library, where validation is before the testing you try to validate. Training is whatever you're trying to validate, where you're trying to train the data. Testing set is you're trying to show the difference between your training and testing, because the entire data input, your input and your target has been mapped into train and test. Your question and answer is being train and test, where you'll be learning majority part for training and you split them into testing. In your splitting also you have that X column and Y column, but the more you have into training part. So that is the reason I always tell Scikit-learn or Scikit-learn is the heart of machine learning library, because if you have attended the previous webinar, we have done everything in mathematical way, and we have used simple 5 steps in with the help of Scikit-learn, which is scientific computing library, has made those steps into 3-4 steps. We import the model, we fit the data, we predict it. Those steps, but in between fitting and predicting, we split into training part and testing part, because we need to validate what is the data, change into training part and testing part. We need to find out the performance and we need to evaluate the result. So that is the reason I always suggest to remember this consistency parameters. What do you mean by consistency? Generally we repeat the same thing, right? If you talk about consistency, that means we learn with consistency. So in the same way, here consistency include how we are trying to fit the data, how we are trying to transform. Because if you remember, we have used in data analysis libraries, we have used the concept of dummies in pandas. Because as I always said, Scikit-learn or any machine learning model needs to understand the data in a single format, that is only in the numeric format. Even if you have string kind of data, that should be transformed to numeric. If it is image kind of data, then you need to train with the help of computer vision or deep learning. That is different part. If you are working with a data set including numbers and characters, then you need to make sure you need to convert that into same format by creating dummies. In the same way, in SQL, and we are having label encoders and one-hot encoders. Those are some kind of transformers where you need to transform. See, train and test data is nothing but depends on your data set. It is not about the example for it. See, we take a data set, something like you study about words regarding to fruits and vegetables. In fruits, you study about all red color fruits, apple or some other kind of fruits. You have learned them, and how you can test them. Whenever you go to any market, you try to spot out them. Instead of, you cannot see the labels directly, you can directly spot out them from the shop store or from the market. See, when we go into data set, we'll try to split them into training part and testing part. It will be entirely X column, Y column. X is your input, Y is your target. But in X and Y, again I split them. You'll understand once we go into it. Right? So inspection and how we try to split the classes and all these things comes into picture when we go to dataset. So this design principle is very much effective. That's the reason Scikit-learn API is pretty much widely used in machine learning. We need not install it because it is directly available in Anaconda platform. If you go for if you're using Python idle or PyCharm or anything, you need to install it manually. Pip install Scikit-learn, pip install Scikit-learn. But if you go for directly using Jupyter and Anaconda platform, you can call that as a machine learning library, or you can use that as a framework, because it provides API for all these tools. It can provide API for statistics and all the things. So that is about the history of it. So we are going to use all these 5 steps today, and we are trying to build a simple classifier using decision tree. So if you see, this is the evaluation pattern. If you see the 4th step here, performance metrics. See, those performance metrics is nothing but you get the marks right at the end. When you write the exam at the end, you get some assessment with the help of percentage, grading, CGPA, you'll get all those things. In the same way, when we build a model, it will try to give out the performance in the format of these metrics, which are called as accuracy, precision and recall, confusion matrix. See, most of the people will get confused with this term confusion matrix. See, this confusion matrix is nothing but it provides your classification report, how we are training data and testing data. See, again, so many people are asking the difference between training and testing. You relate the same thing to your general life. You study in your curriculum, that is your training part, and at the end you write your exam, that is testing part. Because whatever you have learned, you need to be tested. Because in the exam you may get some other concept, but you try to relate the same thing to your previous knowledge, right? So that is how. So this confusion matrix gives you the relationship between your actual values and predicted values. So this is clearly applicable for binary targets. If you have more than binary target, that means if you go for iris species, you have 3 targets. In today's data set, we are having only 2 targets. The 2 targets include yes or no. So here let's go for, because in 3 targets representation, the binary, this representation is not at all understandable. So let's go for the representation of actual values and positive values, actual values and the predicted values. So actual values in the sense, you see the first one, true positive. What do you mean by true positive? Whatever actual your answer is, in prediction also that is saying same thing. I'll go with an example. We'll do this thing when we are into model. I'll tell everything, you just wait for 2 minutes. I'll explain everything, then you can ask the queries. So if you go for true positive, we have done about the Titanic survival rate. So if a person is dead in the actual data, the model is also predicting that he is dead. That is true positive. Actual he is dead, and your model is also predicting in the same way. That is true positive. Whatever the value present in your data set and whatever the value present in the prediction output, both are same. That is true positive. If it is existing, true positive. If it is not existing, true negative. That is true positive and true negative. If you go for false positive and false negative, you see negative is 0. That means that thing has not happened in an actual case, but it is projecting in a real case. False positive. If you go for the prediction wise, false negative, that thing has happened in the actual case and not happened in the prediction case. So false always indicates that is not happening in the actual case. It is happening in the prediction case. True always indicates that is happening in both the cases. True positive, true negative, happening in both the cases. False positive, false negative. It is not happening in the actual case, but it is projecting it in the predicted case. That is the reason false. Positive in the sense it is existing. Negative in the sense it is not existing. You try to relate the same thing to your life. See, doesn't get our output is getting in the format of true positive or true negative. Whatever we are trying to divide our data into training part and testing part, these true positive and true negative will represent your survival. I mean, we will represent the matrix. Whatever we have done will represent in the matrix, and this actual predicted 0 1 0 1. Always you remember true positive and true negative is for making your actual values matching with the predicted values. False positive, false negative in the sense your actual values are not matching with the prediction values. That is the thing. So based on this thing, we have the metrics called as accuracy, precision, recall, and all the things. These are the formulas. If you calculate about the accuracy, see, false positive, false negative, as I already said, if it is not existing in the actual but existing in the prediction, something like Titanic data set, the person is dead in the original data, but the model is showing that he is alive in the prediction data. So once you remember only one thing, if you're trying to relate the data to real senses only, you'll understand false is always opposite of not existing. Your actual data not existing, but your prediction data is telling that it is existing. True always relate to the happening things. You understand, you try to tell me whether he is having COVID but does not show in test means true he is having COVID coronavirus, but it is not showing in the output case. What does that mean? Your actual is matching, but output is not showing. That is a false case. So that is false positive. If actually is not happening, so true negative is not like that. True negative is the something case where it is not existing in the data and the model is also showing not existing. That is true negative. True always gives you whether it is happening or not happening. False always gives you it is not present in the actual data. Please remember that thing. Don't get confused with that part. Right? So now, based on all the classifiers, why would I go for this kind of classifier called a decision tree? We'll see this thing in 10 minutes and we'll go for the execution part, because this classifier is the best one. F measure or nothing but F1 score is the arithmetic mean of your precision and recall. Precision, recall. That score determines how your model is working out better way, how your sensitivity is, and how well that is reacting to the original input. So this decision tree is the the widely used one, and it is related to without any pure mathematics. You can have, instead of complex mathematics, you can see that thing with the logical decisions. So that is the reason the name itself says decision tree. It resembles, like, I can tell a best example of I always prefer, you can relate decision tree to a customer care, intelligent customer care. Something like you can relate that thing to IBM Watson, which is based on logics, or you try to speaking the same thing to the customer agent, right? When you dial the toll-free number, you have the voice telling it out that you press this key, this key for all the things, right? You press one for the prepaid, postpaid, and all the things. You have some set of logical things, right? In the same way, The decision tree also is completely built on logics. It is purely based on tree models. You have node, leaf node, and all the nodes. Our target is to find out the best root node. That is the reason we have two types of decision trees, that even though this is used for both classification and regression, it is similar to your customer care. How? Until and unless it frames all the logics, if that logic is not filled, then a person manually will talk to us, right? You relate the same thing to, the same thing is present in data mining, but here we try to implement that thing with the help of Scikit-learn library. So in this, we are having two types of popular decision trees, which is CART model, that is classification and regression tree, ID3, iterative dichotomizer, where we use entropy and information gain. For CART, we use Gini index because that is purely based on some simple formulas. This is the formula. I have the formulas in the PPT as usual. For regression, we don't write all these formulas in decision tree. We directly call the classifier with the help of Scikit-learn, because the main motive of session is to, you need to use Scikit-learn. Yes, so entropy is nothing but how you measure your impurities. So information gain is nothing but the formula of entropy minus weighted average into entropy of each feature, how we are trying to calculate your each feature. Then you find out the summation of each values, that is summation of all possible values with the failure values, that is entropy. But in general cases, we don't prefer entropy because it forms more number of trees. We prefer Gini index. Gini index is nothing but it is 1 minus summation of probability of success plus probability of failure. Happening event, not happening event, that is the square of the values. It looks something like this, where you try to take up this thing. See, this is how sample tree representation. So target is to find out the root node. See, here I have a simple data set where my play condition is yes or no, that is binary. So how can I see here? So impurities are nothing but whether this kind of features are into your data or not. See, if you have a basket full of vegetables of same type, that is of null impurities. If you have a basket full of different type of vegetables, you have mangoes, you have bananas, you have apples, that is, you're having some full of impurities. So that is how you can say impurities. So here entropy is always the calculation of impurities. So information gain, you try to find out overall information gain from individual feature. That feature can be outlook, temperature, humidity, wind. So you're having 14 attributes. In outlook, you're having again 3 categories: sunny, overcast, rainy. So based on these 3 categories, which one I should choose? If you want to play a game, see, if general in play conditions, you see that temperature should be feasible, what is the wind percentage and all the things, right? What is the wind ratio? So in the same way in decision tree, our target is to find out which feature is best so that I can choose from that. So I'll relate this thing to simple thing and we'll go for analysis part. So how can a customer care agent, something like whatever postpaid or prepaid you call, whatever subscriber you can call to Jio or Airtel or Vodafone, whenever you call the toll-free number, you'll definitely have intelligent assistant, right? It will tell you, please confirm your mobile number. It will have the options prepaid, postpaid, your DTH service or whatever. So how come only these 3 options? Because they are providing only those 3 services and you can match from them. So those 3 services are your root node. So in decision tree, we have the terminologies including nodes and root nodes, leaf, branches, all these part. You can relate that thing to a simple tree. So what is the base of a tree? Roots, right? In the same way in decision tree, finding out root node is very, very important. So in today's session, we'll visualize the tree also with the help of a library called as GraphVis. So here I can say Outlook as my root node. For finding out the root node, we make use of these calculations, which Gini index or information gain. So we prefer Gini index in real senses because they form more balanced trees. So that because every node itself here it is a tree. If here outlook is a tree, wind is a tree, and everything is every node is a tree. But you see leaf node, wherever you don't have any child nodes out of it. That means no further splitting is possible. That is about decision tree. Gini index, that is the performance metric to calculate the, where you need to calculate how you can split the trees and how you can form a decision tree. So based on decision tree only, you can find out the performance metrics, that is accuracy, classification report, recall and precision. Yes, so that is the background part for it. We'll use the same steps and we'll build a classifier with the help of decision tree. So for the data set, that is a data set where we try to perform our analysis. Please download the data set in the meanwhile. We'll go for Collaboratory itself, Google Collaboratory. Yes, download it, open your Google Collaboratory. So classes are always, so label is nothing but your target, features are your input. In train data, you define it into training part and testing part. Once we go into the session, you will understand when we go for the practical part. Hope you know how to use Colab, so I don't repeat the same steps again. Open your Google Collaboratory, open new notebook, because you need not install any packages here itself, because any person with internet connection, obviously he'll be using Google browser, he'll be having Gmail. So that's the reason I always suggest you to go for Google Collaboratory. Once dataset is downloaded, you can see for it will be allocating the data to runtime. I mean, it will be allocating the resources for your drive, should be connecting. If you know how to upload the data, then upload the data set. We'll be going for pre-processing and we'll be reading the data set and we'll be using all the steps. You can see the RAM is around 12 GB, disk space is around 107 GB. Click on your left side files option, upload the data. This is for newcomers, whoever new to this. You upload it from I have it in desktop. I guess I have it here. Need to see. Yes, I have the data. Once it is uploading, it will show you. Reminder: upload files will get deleted when this runtime. Okay, you click on OK, no issues. Once the data is uploaded, it is fine. Yes, yes, we'll start. So you directly import the packages, where you go for numeric packages and you go for reading the data set. Pandas, import numpy as np, pandas as pd. I don't visualize any data, so then you can directly go for it. So here I import a library called as GraphViz. So GraphViz is a graphical visualization software or library where you can see the output of the last PPT slide, right? You have seen the tree. In the same way, your data set will be able to form a tree by calculating automatically the features from your data, where it automatically calculates the values. I mean, based upon the depth and all the parameters, you will be calculating the Gini index. You need not do it manually. Your GraphViz is the library which will do the visualization part. GraphViz, graphical visualization. Then you need to import your Scikit-learn libraries. So from Scikit-learn.tree, so for decision tree, I need to import from tree. You need to import decision tree classifier. You can get the suggestion directly. Make sure you write it correctly. And for the performance metrics, you always import from Scikit-learn.metrics. You import accuracy underscore score, comma. You can get classification report, comma. That is fine. Those are fine. You can get, if you want recall, precision, all the things. From Scikit-learn.metrics, you import accuracy underscore score, classification underscore report. And you can directly go for, if you want to directly call tree, from Scikit-learn.tree for tree models. So sorry, from Scikit-learn import tree. From Scikit-learn import tree, basically for tree models. This is the first step. Always you need, our data collection is done. We need to go for data pre-processing, the second step. So in second step, you need to first import the packages. Your packages importing are NumPy is for numerical Python, pandas is for reading the data set, sklearn.tree for tree model. So if you want to use the decision tree classifier, you need to call it from sklearn.tree. And how you can make the performance measures from sklearn.metrics, you import accuracy score and classification report. Now read the data set. How do you read it? Bank is equal to pd dot with the help of pandas read underscore csv, because read underscore csv is the functionality to read the csv files from sklearn import tree, because that is a tree model. You are directly importing it. You can do it like this, or you can directly import this, because we are building a decision tree. Decision tree is purely based upon the logics formation of trees. It includes root node, which is the basis. Our target is to find out the root node. If we do manual calculation, we need to calculate Gini index or information gain for every feature. It takes very lot amount of time. That is the reason you directly go for decision tree. You read the data set, bank, what is my file name? Bank data. So pd dot read underscore csv of bank data dot csv. So if you want to view the values, bank dot head, which gives the top 5 values. So you can see that the data set including the bank data set, age of the person, whether he is married or not, the balance in his account, whether he has taken loan or not, he has given contact details or not, deposit, whether he is having a fixed deposit or not. So this is something like binary label classification. You can also apply the same process for multi-label. Multi-label in the sense your target will have more than 2 categories. Here yes or no is my category. If you are having an animal data set which includes all the types of animals, mammals, reptiles, all these things, that includes multi-label. Generally, iris data set, all these are comes under multi-label. This is binary, where your target is you are directly using Google Drive, need not give any location. That is the reason I'm using collaboratory. Once you have read the data set, then you can go for data pre-processing steps. How do you go for it? Dot head represents the top 5 values. Dot tail represents the last values. You can go for it. And if you want to see the columns, bank dot columns. That will review the column names. What are the column names? Age, marital status, balance, loan, contact, deposit. That is simple steps which you have already known from the data analysis. Now if you see, you're having some, let me go for, you're having yes or no in loan. If you see, open the Excel sheet, you'll understand that you're having categories in marital status, loan, yes or no, contact. They gave, some people gave contact and some people did not give contact. So you need to create dummies for that, which we have already seen from the libraries, the pandas analysis. So what do? I go for bank 1 is equal to pd dot, I directly go for get underscore dummies. If you want, first you can check the null values, bank dot is null dot sum. First check null values whether you are having in any column, the data is clean, because these steps play a very key role when you are going for analysis. Bank dot is null dot sum. Your data set is clean, but you need to create some categories. If you open the Excel sheet, you have categories in marital status, because marital obviously include married, not married. I mean unmarried. Balance is numeric. Loan, yes or no. Contact, they have contact or they do not give contact. Deposit is yes or no. So for that, I can directly create, no need of dropping anything. Let's go as usual. I define bank 1 is equal to, I create directly dummies for it. pd dot get underscore dummies of, what is your input? Bank, comma, what are your columns? Make sure you have the columns in a correct way. Columns is equal to marital status, I mean marital, comma, because I want to convert the categories of all these things directly. Loan, comma, contact, comma, deposit. You're converting all these categories into, all these columns into splitting. You're dividing it into categories. That means you are directly doing it into categories. You need not have only single value. You're splitting it because you should make your data set clean. Already it is clean, but you're trying to create dummies. Dummies is nothing but you're creating duplicates. So drop first, I think you know what do you mean by drop first. You're dropping the first column. If he's married, in marital status, you have that he's married or unmarried. So I want to drop one thing because if I know one thing, that is fine. Now data set is split into categories. You can go for bank1.head. You can see the categories for it. Marital married, marital single. Loan yes, contact telephone, contact unknown, deposit, and deposit yes. If you apply in place equal to true, then that will be applied. No issues. I want to drop the first thing. Yes, you can also go for label encoder. No issues with that. But I'm trying to make sure that you learn in a simple way. If you're having heavy amount of value, then you can go for label encoding. That is purely from Scikit-learn. Here I'm using because we are familiar with this thing. Whatever the webinars we are doing in a series way, we have dealt about dummies. I want to implement the same thing. Once you have created this, you see the column names. What are your new columns? Bank2 dot columns. Sorry, it is bank1. Sorry, bank1 dot columns, which includes age, balance. You have created dummies for marital, loan, contact, deposit. That's it. Now, this is your second step where you have directly created the data, refined data, etc., and everything is done. Now, the third step is creating a model, right? So, for creating the model, what you need to do, you need to split your data set into training part and testing part, right? So what do you mean by splitting of training and testing? So people always ask me, why do we need to give the training and testing part? Yes, it is always suitable for optimization. Labeled is only correct one because you have directly given over here. You have created dummies for the original columns, and from the data itself, it is converting the strings into numeric, whether it is present 1, if it is not present 0. If the first person is married, in place of married you get 1, in place of single you get 0, right? So this step is modeling. So third step, which includes dividing the data into training part and testing part. So here you come sure with the concept of random state. So always people ask me why we need to split the data into training and testing, and what key role does random state plays. So random state is basically used for reproducing a problem the same every time, because you try to train and you try to split the data into training part and testing part, because it should learn and it should produce the result in a better way. Your data should not change, right? For every iteration, your data should not change. For that, you give out this column called as random state. I'll show with an example. You don't worry why we should give random state. Then it will be pretty clear for you. Problem the same every time. So for this, I'll use from Scikit-learn dot. This is the important step in model selection. You import train. For splitting the data, you have train underscore test underscore split. That is the reason Scikit-learn directly provides you all the libraries. So what data I want to split, I'll give some dummy input because I wanted you to understand how training and testing splitting is done with the help of random state. That is the reason I'm taking a sample example. I take a comma b is equal to, I define some values, np.arrange of 10, 0 to 9 values. I want to form that in an array with the help of reshape. What are the possibilities in reshape? You can give 2 comma 5 or 5 comma 2, right? So that is your a value. For b, you are trying to give range of values. Range is for single dimension, a range is for multi-dimension. Now you split them, train underscore test underscore split. You split the data. So initially, before splitting, let's do one thing. You go for print A and print B. You see how does the data looks like. and then you go for splitting it. This is A, this is B. Now what I'll do is I'll go for splitting. If you want, I'll provide the same thing in chat box. That is in the chat box. You first print A, print B. Print A 0 to 9, B is 0, 5 because range of 5 is 0, 5. Now I'll go for splitting it. You see the output? The values are splitted into training part and testing part. Training part is 6, 7, 8, 9, 2, 3, 4, 5, 0, 1, and that is A, B are splitted. A values are splitted, B values are splitted. This is the A value training part, comma. You can see this is your A value training part. This is your A value testing part. This is your B value training part. This is your B value testing part. Train, test, split, right? You have done it. Now what I'll do, I'll run one more time. I'll copy paste. I'll copy the same thing and you copy the same data. You run once again. What is the difference you can see? Quick one. The values will be changed. Train, test, split. You are dividing your data into training part and testing part. Whatever input you gave, this first one is your entire A and this array 0, 1 is B, 3, 4, 1, 0, 2. Training part, testing part. That entire thing has been splitted. Not only trained part or test part, everything has been changed. You can clearly observe. You can clearly observe your training data and your test data has been entirely changed because you are running once again. You run once again, the values will again change because as I said, if you don't give random state, your values will change for every iteration. That should not be done because for every new data, your model should run every time. That is the reason I define a term called as seeding is something like where you try to change with the help of random state only. Before, if you don't know how to give random state, then seeding is not at all useful. Seeding is for number of iterations. So now what I'll do is I'll go for same thing, train underscore test underscore split off. I define A comma B comma. I define this term called as random underscore state is equal to 1. I assign some value. Inaccurate values in other sense, your model cannot learn in a better way. It gives some different values. If I assign random state, see for this particular set, you have same values. Again, if you apply random state and you run once again, the values don't change because for that set, for that random state, those values are flexibly stored. You cannot change them. You need not change them. That is the importance of random state. That is the reason you need to initialize the random state. If you don't initialize them, you obviously fall into error. So make sure you initialize them. This is the first step in model selection where you try to split the data into. What do you mean by fixing the data? When you give random state, nothing gets changed. For whatever the data is, it will be splitting. Then we go for giving the ratio of training part and testing part. So the best part for giving the ratio is 60-30 or 70% for training, 30% for testing, only to get the better performance. If you train more, you get the better data. You go for train data, train, train, test. Yes, am I clear? So you can assign 1, 2, 3 or anything. Nothing has changed. Shape has not changed. You observe clearly. Don't confuse with that thing. Shape never changes. Shape will be same. The values will be splitting. You clearly observe. So train, test, train, test. So I define train, test. You take from input. So train underscore test underscore. You split the data. What is your input? From bank data, bank 1. You need to take the data from bank 1 because that is your data which has been changed. So bank 1 dot, you need to locate the data. What is your X, comma? I'll come from the last, that is -1 because X should include your input. Y will include your target. What is your target here? Deposits, right? So that is the reason I'm giving directly with the help of locating index location bank 1 dot I locate of Colon includes taking all the values. -1 is the last one. So before -1, x values. At -1, that last values. Then you define here test size. This is very, very important. Test underscore size. Where I have said 70-30 is the better one. And in random state, see, assign some one value. Make sure you write it correctly. I'm giving it in the chat box because this step is very, very important. 70-30. You can write here train size also. Either you can write train size or test size. Then you have done dividing it into training and testing. You apply the algorithm. What is your classifier? Decision tree classifier, DTC. You call the classifier. You get the suggestion over there. You call it. No, it doesn't learn. It will be varying. See, for one time when you run the kernel, the values will be different. When you reinitialize the kernel, values will be different. How can you make that much of inconsistency? It should have consistency. No, you cannot. You can take any kind of value for random state. It depends on your data set. The general one we prefer is start with 1. Based on our accuracy, we try to change it. You can allocate anything, but generally they prefer 45 or 47. Exactly, you don't remember the value. So generally based on type of data set, they prefer. This is after splitting, you go for fitting the data. That is your train data. Always for fitting your train data, train X and train Y. It is not about by-hearting. Again, I'm trying to tell you that machine learning is not by-hearting. You're allocating same set of values. I mean, same set of train data. The values may differ, but the kind of annotation will be similar. It is not that it is by-hearting the values over there. Don't relate the same thing to this. So here, when you fit the training data, you are having some default parameters. If you can see, the criteria is Gini index automatically. Here, maximum depth is none. That means you can see you're not assigning any depth. Here, maximum depth should include how many number of trees, how many number of levels you are forming. Maximum features, those are all null values. I don't define anything. I'll find out the accuracy for training and testing. Then we'll assign some tree values. We'll see that thing now. So these are all features. Maximum depth includes the number of levels in the tree. Splitter, how we are trying to split. Criterion is, see, default it is taking Gini index. I don't touch that thing. Number of samples and how many times you are splitting. See, what is the default value? Random state, none. That is the reason I have applied within the splitting data itself random state. I'm not applying it in the classifier. Once you fit the data with the training part, then you go for prediction part. So predict underscore train. I want to see the training accuracy and testing accuracy. So that's where you see here. Instead of finding out the whole accuracy, I will show you how the training accuracy and testing accuracy are done. Make sure you go with the, because this is something like you build a simple classifier, how you try to split the data, how you try to train with the, make sure that with the help of training accuracy and testing accuracy. For prediction of train data, DTC dot, which is decision tree classifier, you predict with the help of train data. That is prediction on testing training data. Then you need to go for prediction of, because for always for something like when you go for fitting the data, you need to go for the training part, training your dependent variable, training your independent variable. For prediction part, that can be training part and testing part. When you're trying to calculate accuracy and confusion matrix, you go for the X test values. That is different over there. Here I'm trying to show you only getting out the training score and testing score, and then we'll visualize the tree. So X test, I mean train X and test X. Make sure you write the values correctly. Now let me print the accuracy for both the things. That's what I wanted to show you. Let's see how much it has been learned on train data and test data. Accuracy on train data is, how do you calculate accuracy? With the help of accuracy score. Accuracy score is always on your Y train and your predict underscore train. If you are going for individual things, If you're going for directly combining them, always your accuracy score will be calculated by using predictions and your Y-train. Y-train is your target. Always fitting will be on input data and output data. Input X in output Y. Train X, train Y. Test X, test Y. Test Y is being choosing in classification report and confusion matrix. So accuracy on test data is, how do you calculate accuracy underscore score of test Y? You're going for test data, and what is your thing here? Predict underscore test. See, you get here, your training data has been learned pretty good, that is 97%, and your test data has been what? 61%. Because for fitting, you need to go for always X train and X test, and for prediction, you need to go for X test. Here I am predicting with the, and I want to see how much my train data is learned and how much my test data is learned. That is the accuracy I wanted to see. Let's visualize this first. See, here I'm calculating accuracy score for train data. I mean training accuracy and testing accuracy. I mean, see, something like your testing is your final exam, your training is your pre-finals or all the things. So pre-final you are getting something like 90%, but in final you are getting 50%, your model is lost. If you get around 60 to 70%, then your model is going to analyze in a better way. Here I have not defined anything over my maximum depth. I did not give out any trees. Accuracy is your calculation of your, what is your test training part here, train Y, test Y, because here this is for accuracy of training data. This is for accuracy of test data. Always you should have your testing accuracy. No, training accuracy should be higher, and testing accuracy also should be matching with 70 to 80%. You cannot get 100% of testing accuracy. That's what we'll see now. We'll calculate the total accuracy of the model. This is for training and testing. I want to show you the total accuracy. Let's go for it first. How do you define that thing? You define predict is equal to, what is your model name? DTC dot predict of, prediction should always be done on the test data of X. What is your X test data? I gave train X and test X, right? So you need to give DTC dot predict of test X. See, that is your prediction. Then if you want to see the output, you can see predict, you can directly get the values. See, the array indicates 0 and 1. If you see the shape of it, predict dot shape, you get the shape of the data. Now let me calculate the accuracy for it. Then we'll visualize the tree. Print accuracy underscore score of my entire data. What is my test data? Y test. See, don't confuse. For fitting, training part, X train and Y train. For prediction, testing part. For accuracy calculation, you need to go for your Y test. What is your Y test I gave here? I mean train X, train Y, test Y. So you need to take here test Y, comma, what is your prediction? Predict, you can give into 100%. You find out, you're getting same 61.51%. So this is your accuracy of your data. And if you want, you can directly print the classification report. Classification report also same values, test Y, comma, predict. See, your classification report gives you how many values we have taken. Total values, 30% of 10,000 is how many values you are having totally? 3,349. So your precision, your recall, whatever the formulas we gave in the PPT, we are trying to calculate over here. If you increase the depth also, maximum depth you can include in the classifier and you can calculate it. Your accuracy will go on decreasing. That is the reason I did not give any maximum depth. So if you want to increase the accuracy for your testing, so 60% is the better score, because our score is also greater than 60%, it is fine, because this is only 10,000 values of data. This is enough. If you go for more amount of data, you cannot expect 70-80% of accuracy. If you are having some 1,000 values, you can get 80%, 75%. If you want to go again on this, you need to go for your validation. That is cross validation. Here, it is pretty good. Then you can see the F1 score. Support indicates 0, that is deposit. They don't have any deposit. 1, they have deposit. That is how you go for your accuracy score and classification report. So finally, let me plot the graph. How do I plot it? As I have already said, you are using GraphViz because this is very, very important. How you try to plot the graph. See, anywhere you cannot get 100% accuracy. You try to match it to 90%. That's where the concept of where you try to go for grid search parameters, where you try to validate the data. This is a simple thing where you're trying to understand that you're building a simple model. Training, testing, splitting. You are trying to go for train data, test data. We're calculating the accuracies. You are seeing the precision and recall. See, precision is 63, 63, 63. Everything is in the same loop, and your accuracy also same. If you have precision and recall in the format of 40s, then that is where you have lost. That is the reason you need to understand. See, I'm trying to convey that in medical data, if you try to get 90%, that is correct. Even if it is 60% also, he is a COVID-19 patient, right? How can you say 90%? If it is 90%, then he is a COVID-19 patient. If he is having 50% symptoms also, he is a patient, right? Will you agree with me? So in GraphViz, accuracy will depends upon the test parameters. That's what I am telling you. So here we'll try to visualize the tree. For visualizing, you can go for GraphViz dot source of you go for export underscore GraphViz, where you try to import the model. And what is your classifier? DTC, comma. For every GraphViz, you need to give your feature names. Feature underscore names is equal to, what are your columns in train data? Trainx dot. You need not change it. You can increase it by validation. You cannot manually change it. Feature names are your columns. Support indicates how much your test data has been split into training and testing. You give test size as 30%. What is your entire data? Entire data you're having 10,000 columns. Out of 10,000, what is your 30%? 3,000, right? So support always gives you the number of deposit values and number of non-deposit values. So trainx dot columns, and if you want to fill the values, you can go for fill is equal to true. And what are your class names? Whether they are having the deposit or not. 0 is for not having deposit. 1 is having deposit, because GraphViz is the ultimately used library for visualization. Always give your input model, give your features, give your class names. Filled in the sense the values should be filled. And I don't want any output file, because if you try to use the same thing in Jupyter, you need to go in another way. I can share that thing in the same Jupyter file, because you cannot do the same thing directly. Jupyter export underscore GraphViz, just let me a minute. Yes, first thing, I need not import the GraphViz directly. So that is the thing, because you got the error right there. From Scikit-learn.tree, you also need to import export underscore GraphViz. So rectify that thing, because that is the tree model. From Scikit-learn.tree, you need to import export underscore GraphViz. To visualize the decision tree, you need to have the GraphViz library that you can directly take it from decision tree. Basically from Scikit-learn, you can import. It will run. It will try to plot the decision tree. How we have seen the example, the same way you can plot the tree here. It will take some time. See, the tree has been plotted. Let me go up and you can see. You can try to move your horizontal tab. Did you get the tree? In my, I think I need to minimize it. You'll get the tree for sure, which includes your train data and your criteria. It will give you all the things. Yes, let me paste the code. We are about to We have come to the end. I'll paste the code in the chat box. From Scikit-learn.tree, import export underscore graphways. See here, it is giving out very small shape. I think I cannot visualize it here. Let me minimize this thing and let me see. Did you get the tree? Anyone? You'll for sure you'll get the tree, but here you're trying to having more number of values, right? So that is the reason your tree is not visible. In Jupyter, in this Google Collaboratory, you're not getting any errors, but tree is visible over there. Here I'm in bright screen mode. I think I cannot see it. If you got the tree, you'll be having the values over there, which includes criteria and the contact, whatever the features you're having, you can see the same features over there. So the first one will be your root node taking up. Did you get the tree, everyone? See, I cannot visible here. That is the part I'm trying to show you. What I'll do is, I'll try to minimize the depth. I'll give only 2 trees, right? Yeah, it will be visible for you. So for my sense, I'll give only 2 trees. You try to understand. I'll give only maximum depth as 2 so that you can visualize it. Let me give me some 2 minutes so I can make you see the tree and I can explain it so that we can wind off the session. Decision tree classifier. You'll be getting the tree where you'll have all the columns. It is not about the dark mode or anything. We'll try to minimize the depth because you need to minimize the depth so that you can see the better number of trees. I'll just go for the things. Maximum depth, I'll give only 2. Then I'll fit the data because you need to go for always fitting the data. Just 5 more minutes. I can show you the tree, but your accuracy will be reduced for sure. You have given only 2 trees, and let me directly give out the point over here which I have defined. Instead of in place of DTC, I'll give DTC underscore 2. Yes, now can you see the tree in my screen? So for your understanding purpose, I'm giving DTC underscore 2. Yes, so here you can see the root node it has taken as contact unknown. So it is splitting all the features into the root nodes because our first target is to find out the root node, right? So here is less than 0. That is nothing but if it is lying less than 50%, what is the gene index it has calculated? 0.499. Total samples 7813 from the trained data. It is splitting. If it is class 0, yes or no. If it is yes, another feature. So here contact unknown, marital married are 2 different decision trees. So here you can see you are not having any root nodes for class 1. That is called as leaf node. This is for visualization purpose. You can see it here, right? So this is only possible with the help of graphways. If you try to find out the accuracy for this, accuracy will be reduced for sure because you are giving some maximum depth, the accuracy will be reduced for training part and testing part. Yes, did you get the tree, everyone? So this tree represents how your gene index is being calculated and how your model is doing step-by-step performance. You can see the gene index value increasing, but clearly you can see the number of samples has been splitted from 7,813 to 62041609. So DTC2 is nothing but you are increasing the number of depths. I mean you are pruning it. Something like you'll be going for cutting the rose trees, right? I mean you try to make them in a perfect shape. In the same way, pruning is nothing but you have only 2 levels in the decision tree. Pruning is nothing but you are trying to make sure your tree has been split. Yes, did you get the tree, everyone? Here you need to understand whatever the steps which we have followed in the 5 steps. I mean splitting the model creation, model validation, model evaluation. You are trying to make sure, yes, you can create n number of trees. If you give depth as highest value, you cannot visualize it. That is the reason I'm giving maximum depth equal to true. You can calculate the training score and testing score as your part. Obviously that will be reduced. That is the reason I did not give any value over there. Yes, so this is the best library, you can visualize it. And if you want to predict, how you can go for dot predict of your values. That is how you can go ahead because we have already given here. If you want confusion matrix, You can directly go over here. I'll create a new cell so that we can wind up today's session. So print confusion underscore matrix. I think did I import confusion matrix above? You need to import it directly first from sklearn.matrix import confusion matrix. If you did not import, you need to check it again from sklearn.matrix. This is the general representation for every data set you can calculate directly in the beginning itself. Confusion underscore matrix. For confusion matrix, you need to make sure that you need to give you the correct values. I mean, you need to give the whatever you gave in the confusion matrix, test 1, test y, and predict. You need to give the same thing. See, this is how your confusion matrix is. 0, first row, 1. So 1115 is your true values, 945 is your true negative values. If you can add 1115 plus 645, that is 1760. The whole values in the people who are not having the deposit, bank deposit. This is how you get the confusion matrix. From sklearn.matrix, you can directly give out confusion underscore matrix. So from classification report itself, we can come to a conclusion. What are the number of values present in your non-deposit and having deposit? So for visualization, I have used directly GraphViz. And if you want to do the same thing in your Jupyter notebook, you need to add some extra lines. You need to import py.plus. That thing I'll be sharing it in the Jupyter file. You can do it for your own. Yes, is it done? Right. So this is how you can build a simple classifier with the help of Scikit-learn. So the same steps, I'll repeat the same steps: data pre-processing, data collection, data pre-processing, creating a model, model deployment. Final step is in model creation, model validation, model evaluation, and model deployment. Right. So before winding off, I'll make you clear one thing. Data mining is only from the past data. If you go for machine learning, you'll try to make sure that the data is learned with the future data also, because it will learn from experience. That is the thing. And GraphViz can be used for presenting trees for both decision tree and random forest in any ensemble models. That is the advantage of tree models. You can go for regression and classification. Yes.